of mine. In this video, we'll be talking about black hole. So black holes are the strangest things in the universe. Make sure you stay till the end and answer my quiz in the comments below. Okay, if you like the video, please a like would be so helpful and a subscribe would be awesome. And also, as a bonus, I'll put a video on dinosaurs when I get to 30 subscribers. So, come on, subscribe. Okay, so when I talk about black holes, I'm talking about world of theory, because black holes are the most theoretical things in the universe. Actually, one of the most theoretical things in the universe. So black holes come in three different types. There's a supermassive one, there's a stellar one, and then there's a primordial, also known as intermediate. So the supermassive ones are supergiant, supermassive, and they're usually found in the center of galaxies. And we don't know exactly how they form. That's a theory, as I said. Then there's a stellar black hole, which we do know how it's formed, and it's usually formed from a really massive star that explodes in supernova. And they're smaller than supermassive ones. And then we have the primordial or intermediate, which are theoretical. We've never seen one actually before. So yeah, we don't know anything about them. We don't know how they form, but we only know that they formed after the Big Bang, which is, you might say, there were no stars then. How did they form after the Big Bang? Well, the matter was in a form at that time that could form black holes, like primordial, or also known as intermediate. But let's talk about the formation of stellar black hole. When a giant star burns, fuels, like it burns hydrogen into helium, okay, there's a balance. If it doesn't burn anything, the balance will break. And that's the balance between the energy produced by the burnt of a chemical element, for example, between gravity, which is gravity here is trying to crush our star, while that radiation or energy produced cancels gravity out. They cancel each other out. And when the star has no more hydrogen to burn, it starts burning helium, which actually formed from hydrogen. And then blah 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 till we reach iron. Iron, when we reach it, it cannot be burned. And it starts growing in the center of the star. And, and then, because it has no more things to burn, the star, gravity wins and crushes the star into the size of an Earth, which is extremely dense. Trust me, you don't want to get close to it, because any seconds now, it's going to, boom, explode. And this explosion is called a supernova, and I might have explained it before. So, when this explodes, okay, when this star explodes, it actually has two scenarios. One is a neutron star, which I talked about before, and then there's a black hole. The black hole is what we're talking about. The black hole is formed, it's a stellar type of black hole. So now talk about the different parts of a black hole. There's the ergosphere, photon sphere, singularity, and event horizon. So actually, the event horizon is the black thing you usually see around the black hole. And the photon sphere and the ergosphere are the two things orbiting it. The photon sphere is light photons, particles of light orbiting the black hole from nearby stars, and the ergosphere is somewhere where matter is orbiting. They can never stay still. That's impossible. They only have one thing to do: spin in the direction of the orbit. So but I'm not saying that you cannot escape a black hole. If you get too close, yeah, you cannot escape it. Not even light can escape at that position, okay? Light, with the speed of 300 million meters per second, cannot escape it, okay? That's, really cool, okay? So when you enter the event horizon, you got no way coming out. But there's one way to come out if you don't use your chance. If you were in the outer event horizon, you've got a chance of escaping. And if you were in the ergosphere or the photon sphere, yeah, you've got a chance of escaping. And if you were outside that, you've got nothing to do. You just turn on the rockets, I'm out. So now, we get to the singularity, which is the middle part, or the crushed star, the old star which is in the middle. And that's where all the matter goes. We don't know what happens to them. We didn't even enter them. Recently we just got the first image of a black hole, and that's something you can have credit for. So yeah. Now we know the different parts of a black hole, we know the different types of a black hole, we know how does a stellar one form. As I said, the other two are, hypothetical or theoretical. It's time to talk about what happens to your body when you enter a black hole. So it's something called spaghettification. Yeah, I'm not talking about spaghetti, I'm talking about an effect on your body. Spaghettification is, you turning into spaghetti from your feet. So when you get into the event horizon, your body starts stretching from the bottom. So your feet start stretching like a spaghetti. Yeah, if you throw 100 people into a black hole, you might get 100 spaghetti, so I'm not going to eat that spaghetti. Okay, awesome. So when you enter a black hole, you get so like spaghettified that you actually die. You tear apart. You're teared apart. That's what happens to your body when you enter a black hole. So the larger the black hole, the more chance you have of going through the black hole safely. Okay, so that was it for this episode. In the next episode, we'll talk about the Hawking radiation and the black hole information loss paradox. These are two really important things in the field of black holes. Thank you for watching this episode, and make sure you take the quiz. I hope you enjoyed this video. Give us a like if you liked it, and if you don't like it, dislike it, and tell in the comments why you didn't like it. What are the problems, then we could fix it. And yeah, comment down below. I might be able to answer them. Okay? And subscribe too if you want to watch an episode of Dinosaurs. Thank you. Bye.